Hello everyone, welcome back to the another session in Principles of Programming Languages. Today we'll be going to continue the third unit. So we were covered two topics of third unit in the previous sessions. Today we'll start with third topic, which is about local referencing environment. Right, so we started actually in the last video about design issues. The first design issues I'm going to cover in this video. The next design issues will be going to cover in the other videos. I mentioned this point in the last video. Third unit, the rest of the topics is all about the design issues, what you can see over here. If you know the design issues, whatever I am presenting here, that are the design issues which are going to be the next topics. Now, let's see the first design issue, which is when we are defining a subprogram, whether the subprogram variables are statically allocated or dynamically allocated. That is what the first design issue. And the second is, when we are defining a subprogram, can I define this subprogram in other subprogram? These two design issues will be going to cover in this video. Now, let's get started to know more about how variables basically specified in the subprogram. To understand more about this, I'll give an example. Now, let's see that I wanted to take some sum function. So, I am taking two parameters a comma b, some int c, and c is equal to some a plus b and some return c. Now, what variables you can find it out? There are two variables what I have taken in function definition, or else you can say it is a parameters. These two parameters of integer data type. Now, look at this, I have defined some c variable. So, c is a variable which is defined inside of the subprogram. Now, read the first line, you will understand. Subprograms can define their own variables. What is own variable? The variable which is defined inside of this block is called as own variable of this subprogram, thereby defining local referencing environment. The local variable which is referring to this subprogram is called as local referencing environment. When you refer the variable in the same block is called as local referencing environment. Now, so variables that are defined inside subprograms are called local variables because their scope is usually, so that's what we were discussed, the scope of this variable usually to this block, body of the subprogram in which they are defined. And so basically when you talk about the local variables, the variables which are owned to the subprogram, that variables can be defined in two ways. The one way is static and the other way is stack dynamic. This is what most important in the previous exam paper also this question has been asked for 5 marks to differentiate stack variable versus static dynamic variables. This question is important. Now, local variables can be either it is static, it can be stack dynamic. Let's understand what is static, what is stack dynamic. Now, let's see with an example the same. When I declare a sub function, let's say that sub ab. Now, so here I am taking the other variable which is int sum is equal to 0. Now, what do you mean by this? This is what the variable what I have defined in the subprogram, and this variable is called as local variable as per the study what we made in the previous slide, and it is what? Local variable to this subprogram. Now, I am taking the other variable which is int count. Now, I am not giving any value here, I am just closing this. Count semicolon. Did you find the difference in between these two? Those two are variables and these two are own variables of the subprogram. But what is the difference we found? The difference is sum is a local variable. The value of the sum is already mentioned in the subprogram. And this is what static. Static is what? Giving a value inside of the variable, or else making some value as constant inside the variable. And you can keep here static also. If you did not put a static over here, as you are fixing the value inside of the variable, it takes as a static. Now the point is what? Static matlab it is a constant. Fine. Now come to the stack dynamic. When I say it is stack dynamic, dynamic is what? The value is expected to change from every time. It may be by supplying from the user, or else you can do some operations to change the value inside of the subprogram. Anything can happen. The moment when you realize it is a dynamic, value can be supplied by the user, or due to the updations the value can be modified. Finally, the local variables whatever you defined inside of the subprogram can either it is belongs to static or it is stack dynamic. And if local variables are stack dynamic, they are bound to storage when the subprogram begins execution, and those will get deallocated, or else those are unbounded from the storage when the subprogram is terminated. And it is an advantage actually whenever variable is inactive in the subprogram, then memory will get allocated. When it is deactive, then memory will get deallocated. This will be an advantage when we execute the program of recursion. Fine. If you don't have a recursion concept, we say that the static is the best one. Now let's see about advantages and disadvantages about static and stack dynamic. Now I told you this is the question what has came in the previous question paper, PPL question paper. It is for long question. Now let's understand how we can differentiate both. The first difference is what? So we'll be going to talk about how stack dynamic is an advantage for the subprograms. The advantages of stack dynamic. The first advantage is what? It is flexible. It is flexible because as the way I told you, right, that the values can be updated, the memory can be created when the subprogram is inactive. When we call the subprogram, then memory will get allocated whatsoever variables were there. When the moment we terminate out of the subprogram, then obviously the variables will get deallocated. So that is what the flexible. And the second is what? It is essential that recursive subprograms have stack dynamic local variables. And the next advantage is, another advantage of stack dynamic locals is that the storage for local variables in an active subprogram can be shared with the local variables in all inactive subprograms. These are what? Three advantages of stack dynamic. Now let's see the primary advantage of static local variables. The primary advantage is what? Local variables is that they are slightly more efficient. They require no runtime overhead for allocating the memory, deallocating the memory. Why it is a primary advantage? Because as soon as you find a variable with the value inside of the subprogram, naturally we won't think about the repeating the memory allocation. Correct? The way how we'll proceed with the stack dynamic, the same way obviously will not proceed with the static. Now let's see about the disadvantages of these two kind of storage. The first disadvantage of stack dynamic is the first disadvantage is what? There is the cost of the time required to allocate and to deallocate the memory, because every time when a subprogram is being initiated by the program, we have to allocate the memory, which whatsoever variable is defined inside of the subprogram, that memory has to get allocated. And when control will terminate from the subprogram, again memory has to be deallocated. And this is what the concept of our dynamic variables, stack dynamic variables concept. Now, so this is what includes with the cost. That is the drawback. And the next is access to the stack dynamic local variables must be indirect, and static is what? It is direct. we can directly access the value from the subprogram, and accessing of stack dynamic is what? Indirect. So that was the drawback. And now let's see with an example which programming languages will support and how it will support. Now let's see. In most contemporary languages, local variables in a subprogram are by default stack dynamic. Now here the example we were taken from C++ function. You can say even for C, because the syntactical structure of C and C++, most of the time it will be common, excepting of your formatted input and output functions. Most of the syntactical structures are common. Now let's say you can assume this block of the code that we have taken from C or C++. Now let's see here, I have given static for some variable. First of all, before you proceed with the code, you just identify what are locals. Local variable is the variable which is defined inside of the subprogram, right? Now sum equal to 0, count, both are local variables. Local variables are categorized into two categories as per the slide. Now what are those? Static and stack dynamic. So the value which is fixed is called as static. The value which is always keeps changes due to the updations, due to the user supply is what? Stack dynamic. Now sum is what? Static. Count is what? Stack dynamic. So the value will get always updated from the user or due to the updations. Now let's see, the methods of C++, Java and C# have only stack dynamic local variables, and in Python the only declarations used in the method definitions are for global. Any variable declared to be global in a method must be a variable defined outside the method. So we were seeing in the last session how a variable can be global. If you wanted to make a variable inside of the subprogram, we used to have extern keyword to make the variable as a global. So Python uses global variables, and only variables with restricted scope are declared in Lua. Lua is a programming language, and the variable declarations in Lua follows with this type of code. Local sum. All non-declared variables in Lua are global. Access to local variables in Lua are faster than access to global variables. So these are various kind of programming languages which support what kind of local variable strategies. And the second design issue what we were defined in the design issue slide. So the first is what? Are the variables are statically or dynamically allocated? Second design issue is, can I define a subprogram in another subprogram? That's what we were seeing as the second design issue. Now let's talk about nested subprograms. What do you mean by nested subprogram? A subprogram which is defined in another subprogram. Now the idea of nesting subprograms originated with the first contemporary language, which is ALGOL 60. The motivation was to be able to create a hierarchy of both logic and scopes. If a subprogram is needed only within another subprogram, why not we place the definition of the subprogram inside of it? Because static scoping is usually used in languages that allow subprograms to be nested. So the point is, nested subprograms, basically it is an advantage and it gives you some restrictions not to follow in the languages. Let's see which languages will support what kind of definitions of a subprogram. These are the languages which are descendants of ALGOL, because the ALGOL is the first programming language which supported nesting subprograms or else defining a subprogram in another one. Those languages are what? ALGOL 60 and ALGOL 68, Pascal and Ada. These languages will support nesting subprograms. There are other languages which will not support. Many other languages, including all of the direct descendants of C, do not allow subprogram nesting. And recently some new languages were added to support nesting subprograms, and those are JavaScript, Python, Ruby and Lua. These languages will support nesting subprogram, that we can define the one subprogram in another subprogram. Basically C supports calling the subprogram in another subprogram, but defining the subprogram in another subprogram, C based languages will not support. So with this, we'll conclude the first two design issues. We'll meet in the next video to talk about parameter passing methods. Thank you all.